Electricity is behind almost any tool that human beings use. It's involved mainly in information processing and energy conversion. And then you can think about millions of applications of that. So what electrical engineering basically teaches you is how those processes work and how you can apply the techniques to solve new problems.
You need to do a lot of maths, a lot of physics in different disciplines, and you need to be quite creative and like to calculate things and figure out how things are working.
I've always been really practical and interested in technology, so studying maths and physics at school, my teacher just suggested I had a look at it, and I read up on the course and decided it was really interesting, kind of the area I wanted to go into.
When I was back home in Kenya, I was thinking, so what skills do I need to become the female Iron Man? That was literally what I was looking for. And I said, well, I can get to know how to build electronics, and I get to know how to program them as well. So I feel that electronic and information engineering really encompasses the whole sort of skills that I need to just build something cool, and that's what I was looking for.
I applied through UCAS and I gave them my personal statement, and I was invited for an interview. I was definitely a lot more worried about it than I should have been. It was more conversational rather than a test.
When I started in first year, it was a bit harder than I initially thought, but then once I'd realised, oh okay, so I need to work it like this, make sure I don't fall behind on certain things, then it's all manageable.
There was a lot of support in the department. They were able to offer me a one-on-one tutoring session for mathematics. So being able to spend 1 hour per week with someone who's just there to help me figure things out was absolutely useful.
There is anything that you need. So we have a lot of labs, electronics lab, computing labs. We are offered packages of software licenses that are really hard to get. So I think that we are literally provided with anything that we might need.
The way that the students are taught is through a mixture of full cohort lectures where the theory is covered, then they do labs where the theory is applied to a relevant experiment. They also have small group teachings, workshops, and then they have projects to consolidate all that knowledge and link concepts from one module to another.
We have a massive amount of modules that students can choose from in the 4th year. And these modules are very closely linked to research that members of staff are doing, so they're very up-to-date, very novel.
I definitely like the amount of practical work we get to do. I really like getting my hands dirty and actually building stuff, and then you actually get to see this final product that you've finished and that you've made, and it's really rewarding.
We have a very good reputation for sending our students off into good jobs. Because of the diversity of our field and because of its link to a lot of aspects of modern technology, really our students are employed in every kind of company and industry you could imagine, right? It's very, very diverse.
The most important thing that you'll take away is your network, because you are in a room with people from 40, 50 different countries. And those people that you sit next to in lectures will eventually be running the world.
I would say if you want to be able to build something and program it, this is the course for you. It's something that's very ingenuitive. It encourages your creative and innovative side and gives you the actual practical skills to do it. So a lot of the time I build things or program things and I can't believe I actually did it myself. So if you want to be able to do that, I would recommend studying the subject.